أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهارده إن شاء الله هناخد درس جديد في مادة الاستاتيكا. اسمه الدرس الاتزان العام. طبعا احنا عارفين امتى يكون في اتزان عام، لما يكون في شرطين. الشرط الأول مجموع جبري لمجموعة القوى في اتجاه السيني واتجاه الصادي تساوي صفر. تاني شرط إني بجيب مجموع العزوم للقوة ديت عند أي نقطة في المستوى برضو أيضا تساوي صفر. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in static. What is the title? General equilibrium. What is the general equilibrium? Means the algebraic sum of all forces in x-axis, y-axis equals 0. Number 2, the moment of all forces about any point in its plane equals 0. Dear student, look at examples about general equilibrium. General equilibrium, look at the first example. If have a heavy uniform rod hanging to vertical wall with 2 kilogram weight and it's 100 centimeter long, with 2 kilogram weight is hung from a point on the rod 75 centimeter apart from the hang. A tie is attached to the other and keeps to the rod horizontal and it's fixed a point on the wall vertical above the hang. Given that the tie is inclined at an angle 60 degrees to horizontal, find the tension of the tie and the reaction as the hang. Solution. Dear student, look at AB and its x-axis equals 0, y-axis equals 0, these three conditions of equilibrium. The first, the algebraic sum in x-axis equals 0. The second, algebraic forces or component on y-axis equals 0. Third, moment at any point in its plane equals 0. Number 1, we have x1 minus t cosine 60 equals 0. Why? Because we have, look at BC. BC has tension T. Incline the horizontal with angle 60 degrees. Then in horizontal, T cosine 60 degrees. In vertical, T sine 60 degrees. We have, look at, dear student, the tension force. The tension force inclined with horizontal axis with angle 60 degrees. We solve the tension as two components. The first component on x-axis, the second on y-axis. The first is T cosine 60 in horizontal, the second T sine 60 in vertical. Then the first equation becomes x1 minus T cosine 60 equals 0. Then the relation between x1 and the tension is x1 equal half T. This is equation number 1. Look at the second. In y-axis, y1 minus t sine 60 equals sum of two forces equals 4. Then y1 equals 4 minus root 3 over y tension t. We have two equations. The first equation, unknown x and t. Second equation, 4 and t. We need the third equation. We find the moment at point A, or moment at point A equals 0. Then we have force T times the distance or perpendicular distance from A, this AD. After that, we have two forces times the distance 50. The second force T, 2 equals 2 times 75 lengths between the second force T, 2 and the point A. Remember, dear student, when we find moment at point A, what is the forces we have three forces. The first force, the weight of AB equal to midpoint, at midpoint AB, 2 times 50. The second force, 2 times the length between A and this force is equal 75. The third force, tension force, times the distance AD. Then we have equations is T times 100 sine 60 equals 100 plus 150. Then the T equal 250 over 50 root 3. This is the value of the tension force equals 5 over root 3 or 5 root 3 over 3 kilogram weight. Remember, dear student, we have two equations. The first equation is unknown, NT and what? Yes, and R1. After that, by substitution in equation 1 and equation 2, we find the value of x. x1 equal 5 root 3 over 6 from equation 1. From equation 2, y equals 4 minus root 3 over 2 times 5 root 3 over 3 equals what? 3 over 2. Then x1 equal 5 root 3 over 6, y1 is reaction equal 3 over 2. Look at, dear student, when we find the resultant, then are inclined by x-axis by angle alpha, r equals square root x1 squared plus y1 squared. What is the value of our resultant of the two forces? Square root 75 over 36 plus 9 over 4. Answer is square root 39 over 2 kilogram weight. Tan alpha equal y over x. What is the value of y? What is the value of x? Equal 3 over 2 divided 5 root 3 over 6. Answer is 3 root 3 over 2. Then find the value of alpha by using shift tan. 3 root 2 over 2 by using calculator. Measure angle alpha 46 degrees and 6 minutes. Then what you deduce? The value of r equal square root x power 2 plus y power 2 and each direction 46 degrees 6 minutes with inclination with x-axis. Another example. Dear student, look at ABC is uniform rod of length 40 cm and weight 30 kg, can rotate about, hang at the end A. A thin wire is attached at B and its other end is fixed at a point 40 cm apart from A, lies vertically directly above A, such that the rod is in horizontal position. BC equals 10 cm. Find the magnitude of the tension in the wire and reaction of the hang. Solution. Dear student, look at the opposite figure. We have AB. ABC is uniform rod. Its weight equal 30 kilogram weight. Its length 40 centimeter. The weight act at midpoint 30 kilogram weight. At point B, there are attached tension T. Hanging in point D up the point A. Look at, dear student, in triangle ABD we have, which is right angle triangle. At point A, then we deduce length of BD equal square root 30 power 2 plus 40 power 2 equals 50. Then BD equals 50. Remember, dear student, if we have length of AB and the length of AD, also length of DE. To find AE, we use Euclidean property by using AB, AD times AB over DC dB equals EE. Why? Because product of two AB times AB equal product of AE times DB. Then the tension downward. Number 2, the tension T is strength. 3, the reaction of the hang R. 3 forces, AX and AY. Consider X1 and Y1 as direction, X equals 0. Then what you deduce? X1 minus T cosine B equals 0. What is the cosine B? Cosine 60. By substitution, X1 equal 3 over 5T. This equation number 1. Y equals 0 means, look at the forces up, Y1 plus T sine B minus 30 equal 0. Sum of algebraic forces in y-axis equals 0. Then Y1 reaction in hang equal Y1 plus tension T sine V equal 30 or negative 30 equals 0. Therefore, by substitution, we deduce that Y1 equal 30 minus 4 over 5 T equal 2. This equation 2. We have two equations. The first equation, unknown X1T. The second equation, unknown Y1T. We need third equation. What you deduce? Excellent student. We find moment about point A equals 0. Then T times AE minus 30 times 20 equals 0. What is the length of AE? Excellent student. By using Euclidean theorem, we find AE by multiply 40 times 30 over 50. 40 times 30 over 50 equals 12 over 5 equal 2.4. Then by substitution, T equals 24 times T equals 600. Then the T equals 25 kilogram. Then AE equal AB sine B. By substitution, 30 times 3 over 5 equals 24. X1 equals 3 over 5 times 25 equals 15. Then Y1 by substitution equals 30 minus 4 over 5 times 25 equals 10. Then the value of Y1 equals 10. R equals what? Square root X1 power 2 plus Y1 power 2. By substitution about X1 and the X2 to find the resultant equals 15 power 2 plus 10 power 2 equals 5 root 13 kilogram 1. Then find the direction, tan alpha equal y over x. What is the value of y? Y1 equals 10, x1 equals 15, and then we deduce tan alpha equal 2/3, the alpha equal shift 10, 2/3, then measure angle alpha equal 33 degrees and 41 minutes. Another example. Uniform ladder of weight W rests at angle of measure 45 to horizontal. Its ends are rested on smooth floor and against smooth vertical wall. The lower end being joined by string to the junction of the floor and the wall. Find the tension of the string and the reaction at the wall and the floor when a man whose weight is that of the ladder is assigned 3/4 of the ladder length. Solution. We have how many forces? Number 1, the weight of the ladder is W. Number 2, the weight of the man. Number 3, tension of the string. R1 and R2 reaction of the floor and the wall. In equilibrium, x equals 0, then R2 minus T equals 0 or R2 equals T. This is equation number 1. Y equals 0. What you deduce? R1 minus 2W equals 0, then R1 equals 2W. This is equation number 2. We need moment at point B equals 0. Why? We need third equation to solve 3 unknown forces. Moment about point B equals 0, then W times BC plus W times BD minus R2 times AE equals 0. Then AB equals to L. If AB let or suppose AB to L, then BC equal L cosine 45. L over or L root 2 over 2, this length of BC. Look at AB to L, midpoint at point at C, BC equals L cosine 45. Half to L or half length AB, then BC equals L root 2 over 2. Then BD also 3 over 2 L cosine 45, because the length is 3 over 2 L times 3 over 2 L cosine 45 equal 3 root 2 over 4 L. After that, AE by using 45 AB over AB equals sine 45, then AB equals 2L sine 45 equals L root 2, because sine 45 root 2 over 2 multiply 2L equals L root 2. After that substitution, then W times L root 2 over 2 plus W times 3 root 2 over L over 4L minus R2 times L root 2 equals 0. Then the relation between W and L divided by L root 2, then L equals half W plus 3/4 W equals R2, then R2 equal 5 over 4 W. From equation 1, by substitution, T equal 5 over 4 W. This is tension force. Now we are translate to another example. Uniform ladder of weight 10 kilogram and its length 3 meter raised with its lower end A on smooth horizontal ground and its upper end B against smooth vertical wall. It is being kept in equilibrium by join the lower end A by a string to the junction of the wall. And the ground lies vertical directly below B in a vertical plane and inclined at an angle. It's measure 45 to the ground. If a man of weight 60 kilogram has ascended the ladder, find the tension of the string when the man has ascending to a point 2 meter apart from A. Solution. First, we consider the two perpendicular direction EX and EB as respect to X and Y, and resolve the force in two direction X and Y, where look at equation of an equilibrium. The first equation X equals 0, second equation Y equals 0, third equation moment at any point equals also 0. In an general equilibrium, we have sum of algebraic forces in x-axis equals 0, in y-axis equals 0, the moment at any point also equals 0. Number 1, what's the meaning of x equals 0? Look at x equals 0, horizontal forces R2 and T. Then R2 equals T or R2 minus T equals 0. Then R1 also equals 60 plus 10. Then R2 equals T, R1 equals 70. The moment about B equals 0, then moment equals 0, reduce 10 times 1.5 cosine 45 plus 60 times 2 cosine 45 minus R2 times 3 sine 45 equals 0. Why? Because we have two forces downward, 10 and 60. 10. The distance 10 between 10 and moment A, point A equals 1.5 cosine 45. But the distance between the 460 and the point AD or the length AD equal 2 cosine 45. Then after that the distance BE equals 3 sine 45 multiply R2. After that we deduce that 15 times 123 R2 equals 45 kilogram weight. Then by substitution T equal also 45. Another example. Uniform rod of weight 20 kilogram rests in vertical plane with one end on a rough horizontal floor and the other end against a smooth vertical wall. The ladder is inclined at 62 horizontal. Given that coefficient of reaction between the ladder and the floor equals 1 over 2 root 3, prove that the maximum distance a man of weight 20 kilogram weight can ascend up the ladder is equal to half length of the ladder. Solution. Look at, dear student, we let or suppose length of AB equals to L. Then AE equals X by finding equation of equilibrium. The first equation in x-axis equals 0, R1 equals 20 plus 60 equals 80. This is equation on y-axis, but in x-axis R2 equals mu R1. By substitution, then R2 equals 1 over 2 root 3 times 80. What is the value of R1? Then R2 equals 40 over root 3 Newton. After that, we find a moment at point A equals 0. Then what is the forces? We have how many forces? 3 forces. 60 times AC plus 20 times AD minus R2 times OB. Dear student, what is the length of AC? What is the length of AD? What is the length of OB? By substitution, look at AE equals AC equals AE cosine 60. Also, AD equals AM cosine 60. But OB equals what? AB sine 60. Why? Because in triangle AOB sine 60 equals what? OB over AB. Then we deduce that the value or the length of OB by substitution about AB equals to L cosine 60 to L sine 60. Then we deduce that, dear student, 60 times x cosine 60 plus 20 times L cosine 60 equal 40 over root 3. Then we deduce that times to L sine 60. What you deduce? 30 x plus 10L equal 40L. Then 30x equals 30L. What you deduce? X equals L. Then the value of x equal value of L. Dear student, look at the example is very important. What is the important rules? If we have general equilibrium, we have three equations, very important equation. The first equation represents the algebraic forces in x-axis must be equal 0. Also, the algebraic forces, sum of algebraic forces in y-axis must be equal 0. After that, we need third equation. What is the third equation? The third equation, moment at any point in its plane also equal 0. Then, this condition of general equilibrium. Dear student, remember, in general equilibrium, we have three equations. The first equation, x-axis equals 0, sum of algebraic component in x-axis equals 0, algebraic sum in y-axis also equals 0. After that, we find the moment at any point in its plane must be equal 0. Why? Because in the first equation, we know two unknown as x and t. The second equation, we know the two forces are unknown as y and t. Then we have two equations in three unknown forces. Then we deduce the third equation to solve three unknown in two equations. If we have three unknown in two equations, must find the third equation. What is the third equation? Excellent student. The moment at any point in its plane equals 0. After that, the required the value of r. What is the r? Square root x power 2 plus y power 2. What is the x? Sum of algebraic sum of all forces in x-axis. The value of x. What is the value of y? The algebraic sum of forces in y-axis. We find r by using square root x power 2 plus y power 2 equals 0. Find the magnitude of r. Then, what is the direction? The direction of r equals tan alpha equals or tan theta equal y over x. We find the value of y and the value of x divided y over x to calculate tan alpha. After that, tan alpha say equals root 3. After that, we find the value of alpha equal shift tan root 3 to find the value of the theta or inclination r about x-axis. Dear student, this lesson is very important as called general equilibrium. Remember these equations, three equations, sum of algebraic forces in x-axis must be equal 0. Also, sum of algebraic forces in y-axis equal 0 and moment at any point in its plane equal 0. This very important equation. Dear student,